Question 1 should be quite straightforward. It tells you the mass of the ball and it tells you the speed that it's thrown with. So for question 1, we're trying to calculate the potential energy gain of the student. Well, you should know straight away that potential energy gain is mg delta h. And usually that means we've got to put three things into the equation: m and g and delta h. In this question, it doesn't tell you m. What it tells you is the weight. Now if you wanted to, you could use the weight, you could divide by g and find the mass. And once you'd done that, you'd have to take the mass and multiply it by g and multiply it by delta h. So there doesn't seem to be a lot of point in dividing 450 to get the mass, to then multiply by g. We could just say that when we're trying to use mg delta h, 450 is mg. So all we have to do is multiply 450 by delta h to find the energy that the student's gained. For part B, when you've got an answer for A, part B just asks for the energy transferred per second. So it takes 18 seconds for that much energy to be transferred, so it should be a simple matter to work out how much energy is transferred per second. So for question 2, calculate the power of the engines of an aircraft to maintain a speed of 250 meters per second when the thrust is 2.0 meganewtons. So remember that power is the work done divided by time, so that's force times distance divided by time. So we know the force, and the distance divided by time, well, that's what speed is. Because every second it travels 250 metres, so distance over time is 250 metres per second. So you can find the work done in a second, in other words the power, by multiplying the force by the velocity. 3 part A is quite tricky. You have to find the gain in potential energy, but you're not told what height the rocket travels through. There is enough information in the question, but you've got to do a SUVAT question in order to find out delta H. So you've got to put in the values for SUVAT, as we've told you how to do. Put in the values, and we're trying to find, in this case, S. How far does the rocket travel in 25 seconds? If it starts at rest and 25 seconds later it's accelerated to a speed of 220 meters per second. So use SUVAT to find the distance it travels in 25 seconds, and that is going to be what we're going to call delta H. We call it S when we're doing SUVAT, but once we've got that value, we're going to use it for potential energy, so it's also can be called delta H. So once you've found delta H, you can find the gain in potential energy. Part B, much simpler, because you're told that the rocket goes from rest and it goes to a speed of 220 meters per second. Well, finding kinetic energy when you know the speed is really straightforward. For part C, to find the power output of its engine, well, what's the engine done? It's given some kinetic energy to the rocket, which you've calculated in part B. It's also given some potential energy to the rocket, which you calculated for part A. So to find the total energy that the engine has given, you just add together those two values. And then it says, not the energy output, but the power output. So of course you need to know that power is energy divided by time. So all that energy came out of the rocket in 25 seconds. So you can find the power. So question 4 seems a bit of an odd question. It's just an opportunity for you to show that you understand about energy and power. So a 100 watt light bulb is obviously giving off a power of 100 watts. So what you need to do is you need to work out how much energy will that be in 1 minute. Obviously you've got to remember that 1 minute, you don't use minutes in calculations usually, we use seconds. You've got to convert the 1 minute to seconds, find out how many joules the light bulb will use. That will then be the potential energy that this mass has got to lose. So you know the potential energy it's going to lose, you know it's got a mass of 5 kilograms, you know the value for G, so you can work out the value for delta H, how far the mass has got to drop.